In this video, I'm going to show how the points on the ellipse are generated. So how these points here, they're generated. And then we call the distance from here to here is B, and call the distance from here to here is A, and the distance from here to here is C. And then I will also show that B squared is equal to A squared minus C squared. And the equation of this ellipse will be x squared over A squared plus y squared over B squared is equal to 1. To generate the points for the ellipse, so first pick any 2 points that are horizontally aligned. So in this case, I picked negative 8, 0 and 8, 0. So any 2 points that are horizontally aligned like this. And notice that the distance between F1 and F2 is 16. And so next, pick the number greater than 16. So any number greater than 16. So in this case, I picked the number 20. And then next, I want to find all points such that the sum of the distances from the point to this point F1 and the distance from the point to this point F2 is equal to D. In this case, is 20. So let's look at these 4 points. This is M1. It's located as the point 0, 6. And I want to show that the distance from M1 to F2 plus the distance from M1 to F1 is equal to 20. M1 is located at 0, 6. F1 is located at 8, 0. F2 is located at negative 8, 0. So the distance from M1 to F1 is 10. The distance from M1 to F2 is also 10. So the sum of the distances from M1 to F1 and F2 is 20. And it's the same thing here. The sum of the distances from M2 to F1, M2 to F2 will also be 20. Now look at this point V1, which is located at 10, 0. The distance from V1 to F1, the distance from here to here is 2. The distance from V1 to F2 is 18. So 2 plus 18 is 20. Same thing for this point V2. The distance from V2 to F2 is 2. The distance from V2 to F1 is 18. And so the sum of the 2 distances is 20. So we found 4 points, 1, 2, 3, 4, such that the sum of the distances from each point to F1 and F2 is 20. And now we want to find all other points such that the sum of the distances from the point to the F1 to F1 and F2 is 20. So here's another one. So all of these points will have the sum of the distances to F1 and F2 will be 20. So from this point, the distance from here to F2 plus the distance from here to F1 is equal to 20. So once again, any point, all of these points, the sum of the distances from the point to F2 plus the distance from the point to F1 is equal to 20. And now we connect all of these points together, then we have an ellipse. And so that's how the ellipse is generated. So first, pick any two fixed points horizontally aligned. In this case, we picked F1 and F2. And then next, pick a constant that is greater than the distance between F1 and F2. And then find all points such that the sum of the distances from the point to F1 and from the point to F2 is equal to the constant d. In this case is 20. And then all of those points together, they will form an ellipse. And now I want to show that the equation of this ellipse with the center at 0, 0 is x squared over h squared dividing by plus y squared over b squared is equal to 1. And so A is the distance from the center to V1 of vertex 1. B is the distance from the center to this point M1. And C is the distance from the center to F1. So I want to show that the equation of this ellipse is x squared over a squared plus y squared over b squared is equal to 1. Once again, the distance from the center to M1, we'll call it B. The distance from the center to the vertex 1, let's call it A. And then the distance from the center to focus 1, let's call it C. The distance from V1 to F2 from V1 to F2 from here to here is A. From here to here is the distance of C. And so it will be A plus C. the distance from V1 to F1. From here to here is A, from here to here is C. And so the distance from here to here will be A minus C. And therefore, the distance from this point to F1 plus from this point V1 to F2 will be 2A. And so that means that any point on the ellipse, then the sum of the distances from the point to focus 1 and 2 will be 2A. So any point on the ellipse, the sum of the distances from the point to F1 and F2 will be 2A. Next, I want to show that A squared is equal to B squared plus C squared. A is the distance from the center to the vertex. B is the distance from the center to M1. C is the distance from the center to focus 1. M1 is a point on the ellipse, therefore the distance from M1 to focus 2F2 plus the distance from M1 to F1 is equal to 2A. Recall that any point on the ellipse, the sum of the distances from the point to F1 and F2 is equal to 2A. M1 is located at 0, B. F1 is located at C, 0. F2 is located at negative C, 0. The distance from M1 to F1. The distance from M1 to F2 is equal to 2A. Simplify, this is C squared plus B squared. And then C squared plus B squared. These two quantities are the same, so we can rewrite it as 2 times the square root of C squared plus B squared is equal to 2A. Square both sides, then we have A squared plus B squared is equal to A squared. Once again, A is the distance from the center to the vertex 1. C is the distance from the center to focus 1. B is the distance from the center to M1. And we have C squared plus B squared is equal to A squared. And then we could also rewrite it as B squared is equal to A squared minus C squared. And we need this in the next part. And then now let's show that the equation of this ellipse is x squared over a squared plus y squared over b squared is equal to 1. And we have just shown that b squared is equal to a squared minus c squared. Pick any point on the ellipse. In this case, let's pick the point P. The distance from P to the two foci, the distances from the two foci, the sum of the two distances must equal to 2a. The distance from P to F2 is this. the distance from P to F1 is this. D1 plus D2 must equal to A. And so this is what we have, equal to 2A. And then just use algebra and go through all these steps. And we will end up with this. But B squared is equal to A squared minus C squared. So here we have A squared times B squared is equal to X squared times B squared plus A squared times Y squared. And then simplify, we will end up with X squared over A squared plus Y squared over B squared is equal to 1. And recall that the center is at 0, 0. But let's say that the center is at some point h and k, then the equation becomes x minus h squared over a squared, and then plus y minus k squared over b squared is equal to 1. So this is what we were looking for. So the equation of the ellipse with the center at 0, 0 is x squared over a squared, y squared over b squared equal to 1. And now let's go back to the ellipse that we just generated earlier. And so in this case, A is 8 and B is 6. So the equation for this ellipse would be x squared over a squared, which is 64, plus y squared over b squared, which is 36, equal to 1. And now let's vary the a, and then let's see what happens to the shape of the ellipse. And so we can see that as A gets larger and larger and larger, the ellipse just becomes more elongated horizontally. So here's our ellipse again. The value under the x squared is 64. The value under the y squared is 36. And now let's make this number larger than this. And so what we can see here is that if the value under the y square is larger than the number under the x square, then the ellipse becomes elongated vertically. And so that's what the difference is. So here we're back here again. If the value under the x square, if it's larger than the number under the y square, then the ellipse is elongated horizontally. If it's the other way around, then the ellipse is elongated vertically. And that's the end of the video.